This video, we're going to talk about how to write the equation of lines that are parallel or perpendicular to a given line. All of the equations that we're going to be given are going to be horizontal or vertical lines. So all of the equations we're going to be finding are going to be horizontal or vertical lines. Right now, I will talk more generically at the end of the video about how you find the equation of a line that is parallel or perpendicular to a given line. So because these are quite simple examples, I want to actually give you a more general formula at the end of the video. All right, so the first example is that we want a line that's going to be parallel to, so that's the symbol for parallel to, x equals 4 and through the point 3, 2. So it's going to have to be another x equals equation, and because it goes through 3, 2, it's going to have to be x equals 3. Now we want parallel to x equals 0 and through -7, 1. So this one's going to have to be x equals -7. This last example is going to be perpendicular to the x-axis, which is y equals 0, and through -4, 7. So to be perpendicular to a y equals equation, it's going to be an x equals equation, and it's going to be x equals -4. So those are all fairly straightforward examples. Let's talk about what it means to be parallel to or perpendicular to. So parallel lines have the same slope. Perpendicular lines have slopes whose product is -1. Product meaning you multiply them. So more slopes are negative reciprocals. It's another way to say that. Okay, so let's give an example here. So let's look at y equals 3x plus 2. And I want to find a line parallel to that at the point 110. Okay, which is a point that's not on that line. That's going to be important that I don't get a point on that line, because otherwise I'm going to get the same equation. So my slope here, because I'm going to have the same slope, is going to be m is 3, and my point is 110. So y minus y1 equals m times x minus x1. If it doesn't tell you to put it in slope-intercept form, you're fine. That's the equation of the line. Y minus 10 equals 3x minus 3. Y equals 3x plus 7. So there's your equation in slope-intercept form. If I wanted something perpendicular to y equals 3x plus 2, perpendicular at, and I'm going to need to give a point that is on the line now, so I'm going to have to give the point 1,5, because they have to actually touch each other. Where parallel lines don't touch each other, perpendicular lines have to touch each other at the point where they're perpendicular. So y minus 5 equals, and now the slope is not 3, but it's going to be -1/3 x minus 1. So y minus 5 equals negative 1/3 x plus 1/3. So we're going to add 15/3 to both sides, which is adding 5 here gives me y, negative 1/3 x plus 16/3, something like that. So that's very common to have to do that in math. And you'll get into some applications of that as you go along later on. But a couple of the words to watch out for with this are going to be parallel and perpendicular. So that's they're either going to use the word parallel or use this symbol for parallel, or they'll use perpendicular or that symbol for perpendicular. And that's going to be when you need to know to use this. In applications later on in math, we're going to watch out for the words tangent and a tangent line and a normal line. I won't explain what those are right now. We'll make videos for those later when those applications come up, but understand that the normal line is perpendicular to the tangent line at a point that's called a point of tangency. So this is a concept that we will apply later in mathematics to this idea of a normal line, which will be very important later in math and applied math and science. Okay, that's it for this video. And we'll come back next time and find the equation of a line through 2 points. See you for the next video.